everyone, warm welcome to science class. Acid foods can be identified by what test? Acid food can be identified by what test? Of course, you all know very well, children, that is SOR test. Second one, basic food can be identified by what test? Basic food can be identified by what test? Exactly, the answer is bitter test. Okay, with that we'll start today's class. How do acids and bases react with each other? How do acids and bases react with each other? So in the previous class we have discussed about how acids and bases react with metals, and how do acids and bases react with metal carbonates and metal hydrogen carbonates. All those things we have discussed. Today we are going to discuss about how do acids and bases react with each other. Okay, the reaction between an acid and a base to give salt and water. To give what? Salt and water. The reaction between an acid and base to give what? Salt and water is known as neutralization reaction. Is known as what? Neutralization reaction. The reaction between an acid and base to give a salt is known as what kind of reaction? Neutralization reaction. In general, a neutralization reaction can be written as, in general, how we can write neutralization reaction, base plus acid, or acid plus base also you can write. So gives what? Salt and water. This is the general formula for neutralization reaction. So we will perform an activity. Take about 2 ml of dilute NaOH solution. NaOH is nothing but what? Sodium hydroxide, which is basic solution. Okay, in a test tube, and add 2 drops of phenolphthalein. So phenolphthalein is a synthetic indicator. So first point, listen very carefully. We have to take dilute 2 ml of dilute NaOH solution, which is basic solution. In that solution we have to add drop of phenolphthalein solution. How many drops? 2 drops. So already we learned that phenolphthalein solution will give in basic what color? Yes, of course it is pink in color. So as soon as if you add phenolphthalein in sodium hydroxide solution, what color will get? Pink color. So it indicates that sodium hydroxide is a basic solution. Okay, what is the color of the solution? Yes, of course we know very well, that is pink color. Okay, next add dilute HCl solution to the above solution drop by drop. So in that solution what we have to do? We have to add drop by drop hydrochloric acid into sodium hydroxide solution. So already it is in the pink color. So drop by drop if you started adding, so what will happen? See, is there any color change for the reaction mixture? Is there any color change? Yes, of course, slowly the pink color will disappear. Why did the color of phenolphthalein change after the addition of an acid? So after the addition of acid, why phenolphthalein color has changed? Because it is neutralized. So already we know that basic knowledge, phenolphthalein will give in neutral what color? It is a colorless. Okay. Now add a few drops of NaOH to the above mixture. Again if you add in the same mixture in a sodium hydroxide, it turns again pink color. If you repeat this activity, so first the sodium hydroxide, it will pink color, phenolphthalein will turn the solution pink color. After adding hydrochloric acid, the solution become neutral. So in neutral, phenolphthalein will give what color? Colorless. And again if you are adding sodium hydroxide, again the solution turns pink. So like this it will go. So what happened? The reaction of an acid, the reaction between acid and base to give a salt and water, this reaction is nothing but neutralization reaction. In above activity, we have observed that the effect of a base is nullified by an acid. So effect of base is nullified by what? Acid, and vice versa. The reaction taking place is written as, so this reaction taking place can be written as what? Sodium hydroxide, NaOH, sodium hydroxide plus hydrochloric acid will get sodium chloride and water. Okay, I hope all understood. Next topic is reaction of metallic oxides with acid. Reaction of metallic oxides with acid. So in that, let us perform one simple activity to understand very easily. Okay. So take a small amount of copper oxide. What we have to take? Small amount of copper oxide in a beaker and add dilute hydrochloric acid. So first we have to take copper oxide, which is black in color, and in that we have to add dilute hydrochloric acid slowly and with constant stirring. You have to keep on stir slowly, and then you have to add hydrochloric acid in the beaker containing copper oxide. Okay. Note the color of the solution. What has happened to the copper oxide? First one, note the color of the solution. So after adding hydrochloric acid, we have to observe that color of the solution. It is slowly, it is changes. So what has happened to the copper oxide? So copper oxide is black in color. In that we have to add hydrochloric acid slowly by constant stirring. Okay. So after adding hydrochloric acid, we have to observe that what happened to that color. Color is changing. So why it is changing? We'll see the reason. You will notice that the color of the solution becomes blue-green. The color of the solution becomes what? Blue-green. So from black color to it turns blue-green. Why this turns the solution blue-green? What is the reason? And the copper oxide dissolves, and copper oxide completely dissolves in hydrochloric acid. The blue-green color of the solution is due to the formation of copper chloride. Why the blue-green color appears? Because the formation of copper chloride in the reaction. So during reaction, what happens? The copper oxide reacts with hydrochloric acid. It becomes, what happened? It forms the salt, which is nothing but copper chloride. Okay, because of that copper chloride, the color has changed blue-green from black to. Okay, the general reaction between a metal oxide and an acid can be written as. So general reaction between acid and a metal oxide can be written metal oxide plus acid. What we will get? Salt and water. Okay. So now write and balance the equation for the above reaction. We have did one activity, simple activity. For that we have to write equation and we have to balance it. So what? Copper oxide we have taken in the beaker. So copper oxide formula what? CuO. Okay, copper oxide reacts with what? Hydrochloric acid, dilute hydrochloric acid. So hydrochloric acid formula what? HCl. And what we will get after the reaction? What is the formation? Copper chloride. So copper chloride formed, and along with that water also. Okay. So you check whether it is balanced or not. Here how many copper is there? Only one. Here also one. And oxygen, how much have here? Only one. Here this side see LHS or RHS, you have to check. Here also only one oxygen, and here 2 hydrogen is there. So here also 2 hydrogen, and chlorine 2 is there. Chlorine is 2. So this equation is balanced. Okay. And since metallic oxide react with acids to give salt and water. So metallic oxides react with acid to give what? Salt and water. Similar to the reaction of a base with an acid. This reaction is similar to that of acid react with base. Okay. Metallic oxides are said to be a basic oxide. So that we can say that, we can conclude that metallic oxides are basic in nature. We have discussed reaction of metallic oxides with acid. For that we have performed one simple activity. With that we can understand very clearly that copper oxide react with hydrochloric acid and form what will be the product? What is the product? Copper chloride and water. So general formula how we can write? Metallic oxide reacts with acids and it forms salt and water. And we have discussed about the equation, and we have balanced also. Okay. Next one is the reaction of a non-metallic oxide with base. The reaction of the non-metallic oxide with base. Okay. You saw the reaction between carbon dioxide and calcium hydroxide. Calcium hydroxide is nothing but what? Lime water in activity 2.5. So we have already discussed the reaction between carbon dioxide and calcium hydroxide. Okay. Calcium hydroxide is nothing but lime water. Calcium hydroxide, which is a base. Calcium hydroxide is nothing but what? It is a base and react with what? Carbon dioxide to produce salt and water. What is the product? To produce salt and water. So we can write the equation. Calcium hydroxide, which is nothing but lime water, react with carbon dioxide, will get calcium carbonate, white precipitate, which is nothing but salt and plus water. Okay, and since this is similar to the reaction between a base and an acid, so this reaction is similar to that of the reaction between base and acid, we can conclude that non-metallic oxides are acidic in nature. So non-metallic oxides are acidic in nature. So what is the topic? Reaction of non-metallic oxides with base. So previous we have discussed, in this session we have discussed 3 topic, children. First one, reaction of acids and bases with acid and base react with each other. So what will be the product? What is the general formula? Base react with acid will get salt and water. The next topic is the reaction of acids with metallic oxides. So in the metallic oxides also we have discussed that it is similar to that of reaction with between base and acid. So metallic oxides are basic in nature. This last topic is the reaction of non-metallic oxide with base. So this also we have already discussed, the reaction of calcium hydroxide with carbon dioxide. So calcium hydroxide reacts with carbon dioxide, will get salt and water. So what is the general formula for this? This is also same, non-metallic oxide plus as base, and it gives salt and water. So you can write non-general formula like that. I hope all understood. We'll meet in the next session, children. Bye, children.